Hey guys, welcome back to another video. So I've been programming in Fortran for a bit now. I wanted to translate my texture pack or fast pack into Fortran, and so I did that. It's just missing one or two features like being able to get the actual OpenGL and Vulkan positions inside of the canvas, but I'll finish that later on. I just thought I'd take a break now, but I wanted to show you guys it. So basically, there will be a link in the description to the actual file for this. This particular section of the code is MIT. I forget to put the license. I'll have to do that later. And if I forget, feel free to yell at me. So it's basically this Tetris packing algorithm, and it's very simple. And I mean, it does an all right job. It's just pretty naive, but gets the job done. And it also has texture trimming, so you can trim textures as you put them into the texture atlas, the canvas, the packer, whatever you want to call it. So I took these 10 images from the texture packer from the Piston developers, and that's why the license shows the Piston developers license there. And as you can see, it's just a bunch of cubes with different numbers on them, and like stuff like this is for testing the trimming feature of it. But we can run a quick test of this, and it'll just dump a file into the root directory here. So let's do that. So just test it, and it made a new file. And so here's that new file. And as you can see, it's a slightly different algorithm than from what I witnessed or what I was looking at in the Piston developers texture packer, but it seems to have the same effect. It's just a lot dumber. So do with that information what you will. But as you can see, I got a gap here of 1 pixel, and it's kind of hard to see on this background, but it's doing the job. And so there's also, we go into our test suite. So we'll close this and go into the translation. If we make this 20, this canvas automatically expands itself, so we can end up with different results. So you can see sometimes it's not that efficient, especially the fact that it's super naive. It'll just find a spot. It's basically trying to shove everything up to the top left, and if it can't find a location where it fits, it will expand the canvas. So when you hit stuff like having number 8 here, so we did 1, 2, 3, 4, 5, 6, because the canvas was only this big, and then 7 went there, and then it expanded, and then it found this. This must be closer than this, but I don't know. It is what it is, basically. As long as it doesn't take up too much space, I'm okay with it. What I could do is I could reorder everything from the biggest to the smallest, and then stream it all into the texture pack there that way. But I really don't feel like doing that. This is efficient enough for me. Maybe down the line I'll create a new algorithm to do that, but right now this is good enough. And if you're wondering how this is happening, so there are bindings to Nothing's STB image library, and which is actually a Linux package now, so you can install this on Linux. And I forgot to space this out properly. I keep forgetting to do stuff like that. Yeah, it's a Linux package now, so you can just bind to it. And if we go into the configuration file, I just have a binding right there, and it's just statically linked, I believe. So that's nice. But that's about it for now, guys. When I start doing other stuff, I'll show you, And I guess if you've watched this far, I'll show you something else. So there's actually bindings to LuaJIT in here, and I actually have an API. Let's see here, and this uses the LuaJIT or the Lua plugin for VS Code, and it allows you to statically type Lua. So if we, let's see here, make there's a texture counter and everything. So usually this runs at 16,000 FPS, but OBS absolutely destroys my my frame rate for some reason. So I don't know. I don't know why that happens. It probably has to do something with timing or something. But anyways, guys, thanks for watching, and I hope you have a great day.